Let's do another one. Use partial fractions to evaluate integral 3x squared minus 7x minus 2 all over x cubed minus x. Alright, what's the first step to do? First, we try and obtain the partial fraction decomposition of this complex expression. And what's the first thing to look for? The first thing to look for is, can you factor the denominator? Can you factor the denominator? First of all, you see a common factor there, x. So that will be x times x squared minus 1. And x squared minus 1 can further be factored as x minus 1 times x plus 1. There you go. So that would be 3x squared minus 7x minus 2 over x times x plus 1 times x minus 1. We have 3 linear factors. So how will you address that in rewriting it in the partial fraction form? You will write it as a over x plus b over x plus 1 plus c over x minus 1. You got 3 linear factors, so we use 3 constants. Okay, well, now the routine thing that we do. What's the routine thing? Take the common denominator, which will be x times x plus 1 times x minus 1, and then construct your numerator. Alright, tell me, how do you construct the numerator? What will x be multiplied by? X will be multiplied by all the factors on the denominator except the denominator of this. In other words, a will be multiplied by x plus 1 times x minus 1, plus b will be multiplied by x times x minus 1, right? Plus c will be multiplied by x times x plus 1. These skills you know already. So we will write it like this. This will be a times x plus 1 times x minus 1 plus b times x minus 1, bx times x minus 1 plus c times x plus 1. Okay, now I have put them in red colors so that you can see them a little more clearly. Alright, now the denominators, this denominator x cubed minus 3 is the same as this denominator, which means we can equate the numerators on the left and on the right. That gives you 3x squared minus 7x minus 2 is a times x plus 1 times x minus 1 plus bx times x minus 1 plus cx times x plus 1. Well, because we have 3 constants a, b and c, we need to reduce 2 of them to 0 if you want to find the third one. Can you find a way? Remember, this is an identity, which means you can use any value of x, any convenient value. Now, can you find a convenient value of x that will reduce 2 of these constants to 0, a, b and c? You need to reduce 2 of them to 0 to find the third one. Alright, what will that be? There are a couple of options. If you choose x equal to 1, this will go to 0 and this also will go to 0. Another option is if you choose x equal to 0. Look at that. X equal to 0 will reduce this to 0 and that to 0, and you can find a. That's the way to look for it. So let's set x equal to 0. That will eliminate b and c. We can find a. Let's do that. Set x equal to 0. That's the most convenient one. So that will make 0 minus 2 equal to a times 0 plus 1 times 0 minus 1. Is that right? Replace all x's by 0. Plus this will become 0 and that will become 0. And what is then left over? The left hand side is negative 2. The right hand side is, look at this, this is plus 1, this is times negative 1, that will be negative 1 times a. Negative 2 equal to negative a, and that gives you A equal to 2. Very easily we got the value of A. Alright, let's go and find the other constants B and C. What will you do next? Well, if you put x equal to 1, it will reduce this term to 0 and this to 0. We can eliminate A and B and we can find C. So let's set x equal to 1. Replace all x by 1. 3 times 1 squared minus 7 times 1 minus 2 equal to A times 1 plus 1 times 1 minus 1. Is that right? That will go to 0. B times 1 minus 1 plus C times 1 plus 1. That will give me 3 minus 7 minus 2 on the left side. This is 0, this is 0, this is 1 plus 1 is 2 times C is 2C. And that gives you negative, this is negative 6, is that right? Negative 9 plus 3 is negative 6 equal to 2C, or C equal to negative 3. Well, once you have the values of two constants, then any x value will be alright because you know the values of two constants and we find the third one. Alright, let's set x equal to negative 1. Well, actually if you set x equal to negative 1, A will be eliminated, C also will be eliminated, we can find B. Alright, and that's what you have, and that will give you B equal to 4. Okay, that's not a big problem for you. Now you have the values of A equal to 2, B equal to 4, and C equal to 3. Therefore, let's write down what this expression is. So we have 3x squared minus 7x minus 2 all over x cubed minus x now becomes A over x, which is 2 over x plus B is 4 over x plus 1, and C is negative 3, will be minus 3 over x minus 1. Replace your A, B, and C, and that's equal to, that minus will make this sign negative. Well, we can now integrate this. While integrating this quantity is very complex, integrating this will be very simple because we can integrate each of these terms separately. Alright, so integral of 3x squared minus 7x minus 2 over x cubed minus x is now the same as integral of that quantity, which you can break into individual integrals. That would be 2 integral 1 over x dx plus 4 integral 1 over x plus 1 dx minus 3 integral 1 over x minus 1 dx. Well, these actually do not need any substitution, does it? No, because integral 1 over x dx is ln of x. Integral 1 over x plus 1 dx is ln x plus 1, absolute value of x plus 1, and same here. So that will be 2 ln x plus 4 ln x plus 1 minus 3 ln x minus 1 plus c. And 2 ln x is ln of x squared. 4 ln x plus 1 is ln of quantity x plus 1 to the power of 4. And minus 3 ln x minus 1 is minus ln x minus 1 quantity raised to the power of 3. There you are. And this can be combined into 1 ln quantity. How is that? Now these two are positive. That means they will get multiplied and this will go to the denominator. Is that right? So this will be ln of x squared times this quantity divided by that quantity. There you go. So that's equal to ln x squared times x plus 1 to the power of 4 all over x minus 3 to the power of 3 plus c is that integral. You can see by breaking down into these partial fractions, we were able to integrate it without any pain. Very simple form of integration. All right, let's do another one. Use partial fractions to evaluate integral 2x minus 3 divided by x minus